right. My intention was to get started a little earlier than this, but having to set this workstation back up again took a little longer than what I had anticipated. So I think we left off yesterday with we stopped with a lot of the aliphatic compounds. So we'll review some of the aromatic compounds. In other words, that's what your benzene rings are when we're dealing with those types of naming, or if it's the reactions that accompany the aromatic compounds. So with that, one aspect we could say is, okay, how about we do this? Illustrate the pathways of, I think I just usually use toluene. That's probably one of the most common ones. In this case, illustrate the pathways of toluene when reacted with, we'll just go ahead and go with chlorine, I guess. And one reaction, okay, the catalyst, oh, that's not right. The catalyst, if I don't put this right, I'm gonna think it's about someone who goes and buys cattle, a catalyst. Huh. How's that starting to funny right away? Okay, a catalyst is, we'll say, heat. Okay, and the other, oh, I don't know, we'll go with, I don't know, nickel chloride. We'll go even more specific, nickel 3 chloride. Okay. So in this case, you have two separate reactions, okay? Because if you're well aware of this, and when we follow our flow charts, okay, with this you're going to get three different types of compounds, okay? And we'll just go ahead and go with the order that we have wrote down, because when we look at this, what we're reacting chlorine with is going to go in a different path when we're adding heat as opposed to this catalyst here, okay? So, let's go ahead and put our toluene on there, okay? And most common spot would be up here. So here is our toluene, okay? We're adding chlorine, okay? Here's our substance that we're adding. The first one we said was heat. Okay, so upon doing so, we're adding heat here. And then I'll put the other reaction beneath so you can actually see how both of them are changing as we go. So then, or I guess I wouldn't say changing, but how they're essentially different. So I'll just go ahead and put the toluene there. And in this case, again, we're adding chlorine, but our catalyst is different. Here we've got nickel chloride, or nickel 3 chloride. So I'll go ahead and let you get caught up for just a moment and see if you can remember what your products are going to be on this side, whether one of them is going to have two products, one of them is just going to have one. Just go ahead and take a moment to work on that. Okay, so we'll go ahead and finish this here. All right. If you thought that this had two products, you would have been correct because of what, or incorrect, sorry. When we're looking at our catalyst here, because we're adding heat to this, okay, it's going to attach in a separate manner. So that one is not going to work. Okay. Let's try this one. Oh, yeah, well, we're on a roll here. There's two. Let's just go back to, all right. We know that this one's going to work. Okay. So because we're reacting that with heat, okay, some of you, you're fine doing this using the molecular formula, but until we said you get a really good understanding of this, and perhaps some of you already do, I would suggest you stick with the structural formula. In other words, where that methyl group is branching off, okay, using the structural formula of CH3 in this manner. But if you're more comfortable leaving it like this, that's fine. But the typical mistake that we said in class that could possibly happen is, yes, we understand that because of this catalyst, that chlorine is going to add to it. This is probably the most common mistake that we see, okay? I mean, you got the right idea that this is going to attach with your methyl group, but it's not written correctly, okay? If you always use this molecular formula instead, probably have about a 95% chance of getting that right every time. But if you choose this, well then you have to take one of those hydrogens off of there and use CH2Cl, okay? Because if you use this formula, then you just attach that on there, then we see we got CH2 and that Cl, okay? And it gives you the same results there. Okay, either way, whatever you're more comfortable with, again, so a lot of you are taking this class for a reason, because not only are you going to see this in the future, but all of you are of high intelligence, okay? So, and unfortunately, you got to listen to talk about stupid jokes. Okay, but anyway, here is your product for chlorinating toluene with heat, okay? So if we are going to chlorinate toluene with a catalyst, in this case, a metal catalyst, if you said you're going to get two products with that you would be correct, okay? Because now you need to look at what your directors are, okay? And with that, okay, we're going to go ahead and put our toluene there. And I'm kind of running out of space here, so I'll make this one a little smaller. Okay, get the idea. So what we mean by this is, what type of director is this, okay? Since this is a metal catalyst instead of heat, when you look at the upper left-hand corner of your flow chart for those aromatic compounds, this is where you probably have this wrote on there for some of them, and then that for your other ones, whether this is an ortho and para director or a meta one. So the meta director is just associated with nitro compounds or NO2. Then your ortho and para directors, as we know, are all alkyl groups, okay, which this is, or C2H5 or propyl group C3H7, okay. Phenol is also an ortho para director, or I guess I should say OH. And then all halogens, okay? All halogens are also ortho and para directors. And then finally, the fourth one is an amino group. Is also considered as an ortho para director. So however it is you want to react this with or attach it, here is where one would go because it's in that ortho position. And the para position is just straight across where you would write it, like so. Those are the two products that you would get for reacting or chlorinating toluene with a metal catalyst. Okay, so maybe just a couple of naming these aromatic compounds, because with a little bit of luck, we'll be back in session tomorrow. But hopefully we found this helpful, just putting a little bit of review of materials that we haven't seen for quite a while. Okay, I don't think this is eraser very, oh there, I guess that's a little better. You put a little muscle in that, I guess. Okay. Well, sitting on the couch drinking coffee, that's really not helping. That's not what we're doing. Trying to get all this ice out of the downspouts. Anyway. So, let me go ahead and spray some of this on here. Okay. And if some of you are tuning in, okay, I always give you a hard time. Maybe you're outside helping pops on the farm. You know who you are. So anyway, with that, we'll go ahead and continue on with this. Okay. Hopefully I didn't start that too early. I'll just do a couple of these. Okay. We're not really going to go gangbusters on this. We'll go ahead and put NH2 there, and we'll go ahead and put an NO2 group on there. And since we did toluene before, we'll go ahead and put one of those there. Okay, this was one of the products that you had earlier. We'd already established that this is toluene. Okay, so there's different ways that you can name that. We can do, if you like the numbering system, okay, remember this would be ortho-chloro toluene. Okay, because it's right next to there. And then your other product that you had in that reaction, when it was straight across, then would be this here. Now we would just change that to parachlorotoluene, okay? Because when you're using these these letters, you're just designating them as a substitute for the numbering system then, okay? But what happens if you have both of these on here? Well, then you can no longer use this. The common name we can still use. That is your number one position right there. So in this case, okay, since this is number one, we've established that because this is your common name here. Okay, so are we going to go counterclockwise or clockwise? Well, of course, this gives you a lower number. So in that case, we've got 2 and then 4. So we've got 2,4-dichlorotoluene. Okay. All right. So go ahead and take a moment to calculate or decipher what the name of that compound is. Because perhaps I'm going a little too fast. But I like to try to keep these around 20 minutes at the most, because let's just face it, there's a lot of distractions at home. Okay, so yes, this does have a common name. Okay, so if you would have done this, aniline, that would be correct. Of course, this would be methylbenzene as well, but I think we had established in class, a lot of you students were choosing to use the common names. If we wanted this, it's also aminobenzene, okay? Just like you could say that this was methylbenzene instead of toluene, okay? So for the most part, you're probably utilizing aniline. So where is this in regards to this aniline? Well, you can either say 3-nitroaniline, okay? But probably more commonly, you're just going to use the letter designation that is 2 spots away, and that would be the meta position. So meta-nitroaniline. Okay, so we're right at about 14 minutes. I think that's probably enough for today. So we still have tomorrow and Friday. Let's keep our fingers crossed that we're back in school tomorrow. So with that, I'll leave off with you there. So we'll catch up to you next time. Oh, wrong mouse.